Elena Irwin, probably known to many of you in terms of lots of different topics that she's worked on over the course of her career. In addition to being a professor at The Ohio State University, she's also the faculty director of the Sustainability Institute there. Has been doing a lot more interdisciplinary work, I think, the last maybe decade or so of her career. And she's going to share some of those perspectives with us today about doing that kind of work and integrated work across disciplines and with different techniques and models and those sorts of things. Please welcome Elena Irwin.
Nice and short and sweet. Appreciate the short and sweet introduction. Well, thank you guys. Can everyone hear me? Super happy and excited to be here. Was very distressed when I saw that my flight had been canceled as of 11 p.m. last night, and thankfully it's an easy drive. So in hindsight, perhaps that's what I should have done to begin with. But thank you so much for the opportunity to be here and to speak and to share some thoughts and some of my recent research looking at integrated models and sustainability. So today I want to talk about kind of three parts to the talk, but really that second piece is going to be the major piece of where I'm going to spend most of my time today. I want to just, since I put sustainability science in the title, I thought I should try to define it for you, but we won't spend too much time on that. I do want to ask, what is the role of economics in sustainability? The short answer, in case you don't get anything else from the talk, is economics is absolutely at the heart of this. And there's a long and deep theory and tradition in sustainability of economics. But there's been lots of other threads of sustainability that have developed over time. And so I want to spend a little bit of time thinking about that. But mostly I'm going to link this to some recent work, actually work that's been going on for a while, but continuing on integrated models of agricultural watersheds, looking at both the land management, land use side of things, as well as the watershed and water quality impacts, largely coming from looking at the Lake Erie Western Basin, the harmful algal blooms, huge issue in that area. You all may recall back in 2014 with the closure of the city of Toledo's public drinking water system for 2 days. That was a huge wake-up call for many people. It continues to be a front issue burner issue for the state of Ohio. The governor's named water quality and HABs as one of the top 3 policy actions of his administration, and he's a Republican governor. So it really is a pressing issue. This work has been funded from a couple different sources, NSF, Coupled Human Natural Systems grant, as well as currently an Infuse stands for Innovations at the Nexus of Food, Energy, Water Systems, also from NSF. And then I want to share just at the end, so Ben is in charge of keeping me on time, some results from the Finichel et al. Survey that some of you may have seen and even hopefully participated in, where we were interested in looking at what are the impressions that people have of doing interdisciplinary research, and what are the motivations, and what are the trade-offs that we assign to publishing in disciplinary journals versus interdisciplinary journals. And so I want to wrap up with that. Before I go any further, I want to acknowledge, if anyone's done interdisciplinary work, how many people here have done some form of interdisciplinary work? Awesome. Okay, maybe I'm preaching to the choir then. But as you all know, most often, this is not always the case, but most often interdisciplinary work is highly collaborative across multiple disciplines, which means big teams of collaborations. And I say that's not always the case. You can actually have an amazing interdisciplinary collaboration with one other person from a different discipline. So it's not always the case, but it often is. And certainly in the years that I've been doing this, that has been the case. So I just wanted to acknowledge, I didn't have pictures of everyone, but at least I have their names up here. And you heard from Hong Xing earlier this morning. She was part of that team and has gone on to, as a graduate student, and now has gone on to Lafayette University. And Wendong Zhang, who you're going to hear from later this afternoon at Iowa State, also part of our team at one point in time. So 2 wonderful superstar graduate students who were benefited greatly from their presence on these teams. So I threw that term sustainability science out there, so let me offer a definition of it. This is from Bill Clark, who's at Harvard University. He's a geographer. You know, the thing is, sustainability science is a lot of what we do. I mean, it is focused on sustainability issues, which have to do with coupled human-natural systems. It is integrated research from multiple disciplines, and it is engaging the world. In other words, it is policy relevant. I mean, that sounds like a lot of pretty much what environmental resource economists do, with the additional twist of it being interdisciplinary. So that's a broad setting of the table. Let me get a little bit more specific now in terms of perhaps something that's a little bit more familiar from an economist's point of view, which is talking about sustainability and thinking about how do we assess sustainability, right? So we are in the mindset of having, you know, so we have a very robust theory in terms of welfare economics, and weak sustainability really comes out of that tradition. It is fundamentally grounded in the theory of welfare economics, and goes back to the solo growth models of the mid-1970s, and the Hartwick rule, which came out of that 1974 solo growth model, which essentially came up with a rule that has formed the foundation of weak sustainability being defined as non-declining social welfare over time. So the Hartwick rule essentially says that a constant consumption in the economy over time is possible if we are extracting our resources at a rate at which the resource rents are equal to our investments in terms of investing in capital growth over time. And so if those things are equal, we have a net investment of 0, and that results in constant consumption. And so that's kind of the foundation of the idea of weak sustainability. Weak sustainability has many assumptions embedded in it. One of those assumptions, and it comes from the specification of the model, which is just a simple Cobb-Douglas production model, is that there is unlimited substitution across different forms of capital. So across different forms, within natural capital, but then also across natural capital, human capital, manufactured capital. And so that is you know, one of the important assumptions that's embedded in that. To make this a little bit more tangible, Dasgupta and others much later came along and said, hey, look, there's a correspondence between welfare and wealth, and that we can approximate welfare with this idea of comprehensive wealth, or sometimes people call it inclusive wealth, with the idea being that if we look at our capital stocks and we are valuing them with constant shadow prices, so this is for short periods of time, we can look at changes in those capital stocks. We can add that up through the shadow by translating them into values with the shadow prices, and non-declining changes in that measure, that inclusive wealth measure, is one way of operationalizing this definition of weak sustainability. And you can see there's some examples of this. If you're familiar with what the World Bank has done in terms of comprehensive wealth, they've been doing this for a while now. The UN had a study that Dasgupta and others led a few years ago. This is a picture from that, looking at a national level in terms of the average annual growth rate of this inclusive wealth measure that is adding up natural capital stocks, changes in natural capital stocks, human capital stocks, manufactured capital stocks, and then also accounting for things such as carbon emissions. Now, as I said, weak sustainability has a lot of assumptions built into it. I mentioned the unlimited substitution issue. That's a big one. You know, the other issue is that we're saying that we can approximate sustainability over time through kind of this linear adding up relationship. Pretty much ignores things like non-convexities, which we know are very common in ecological systems. Non-convexities that can lead to thresholds and non-linearities. And so, you know, while it's maybe a good first approximation to thinking about how do we define and measure sustainability, it's not really getting at really what, if we think about it, the heart of the concerns are about sustainability, right? That we're pushing up against some limits, and that in doing so, we're going to go beyond some magical threshold that will push us into this land of unsustainability. So that's a big issue. Another big issue is that the weak sustainability foundation makes an assumption that we're really dealing with a closed system. So, you know, it's perfect for the world. The world is a closed system. But once we start trying to drill that down to a nation state, becomes a little bit more problematic to assume that that's a closed economy. And certainly if you're thinking at a regional level, which is really where a lot of my work is focused, it's very difficult to make that assumption that this is a closed economy. And so the question is, how do you think about regional sustainability in this open world? A world in which we have trade flows, migration, right? Things are moving around. And so how do we think about what sustainability means in that world? So I'll come back to that. But some of these concerns, particularly on the substitution and on the threshold issues, have led a lot of people, mostly non-economists, to think about strong sustainability. So as you all have probably heard about the whole planetary boundaries published. It was back in Science in 2015, and there's been some updated work. But the idea of planetary boundaries is an example of strong sustainability. This idea that there are absolute physical thresholds or ecological thresholds, and that if we go beyond this, we'll be in some realm of unsustainability. This is not really tied to any kind of welfare idea. And some people may say that it is an approximation for thinking about human well-being and the fundamental dependence of humans on the ecosystem. But it's not really thinking at all about trade-offs. And so it's very different from the kind of approach that we're used to and that we would naturally think about. And so while we would tend to reject this approach, it's pointing to some important things which have to do with this idea of nonlinearities and dynamics. When you think about, so that's all kind of like the conceptual piece of this. And as we move towards more practical implementation of sustainability, if you've ever looked at sustainable Seattle or any number of cities that have sustainability programs, what they're usually doing is just a dashboard approach, of indicators, which is not connected at all to welfare. It's not connected to weak sustainability or strong sustainability. It's just a bunch of indicators. So it's really hard to know what to do with that. Strong sustainability metrics, things like carbon footprint or water footprint or things like this, these are all just physical measures of things. Again, they're not connected to welfare. It's hard to know what to do with that. So these assessments, we're left with little guidance, particularly in terms of policy. And if ultimately what we care about is informing policy, we really need something that is more directly connected to theory of welfare economics, but is also practical and capturing some of these important trade-offs that the traditional measures of weak sustainability do not. So all of this led us back in an article that we published a couple of years ago in the Annual Review of Resource Economics, to think about an approach called weak sustainability plus. And so weak sustainability plus is this idea that, all right, we have a welfare theoretic foundation in terms of our modeling approach, but it is one in which we are accounting for more of the realism in terms of the ecological dynamics or the physical biodynamics, as well as possibly on the human side. There might also be some important sources of heterogeneity that aren't captured in the highly stylized models that have typically been used to think about sustainability from an economics point of view. And so the argument is that we need integrated models that have more realistic representation of both the human side as well as the biophysical side, that are dynamic and that can capture perhaps some of the important threshold effects or nonlinearities that we may encounter when we're thinking about questions of sustainability, that can also be used to simulate under different policy scenarios future outcomes, and thus thinking about sustainability over time, which ultimately is really what we mean by sustainability. So that's kind of the lead up and the setup for what I want to really kind of spend a little bit more time talking about now, which is some examples of these integrated models. So as I said, a lot of my work has looked at integrated modeling in an agricultural watershed perspective, thinking about land and land use and land management decisions made by farmers or operators of farms, and the impacts of that on water quality. And so this is truly, a ripe question and a ripe problem for an integrated modeling perspective, because if you want to try to understand what are the right policies, we need to understand, if anyone knows anything about the political economy of agriculture, we know that regulation is just simply not on the table. And so we have to be thinking about voluntary mechanisms, economic incentives that are going to, quote unquote, get farmers to do the right thing. So the responsiveness of farmers to those incentives matters greatly for the effectiveness of those policies. So if we want to even do a benefit cost analysis of policies, we need to understand not just the responsiveness of farmers, but also the responsiveness of the natural system. And so this is a perfect example of why we need some kind of integrated modeling approach. As I said, a lot of my work has looked at the Western Lake Erie watershed. This is up from this area of the Western Lake Erie. This is the Maumee watershed, which is the largest watershed in in the Lake Erie Basin. And it is dominated by agriculture. It's about 85% agriculture. I'm sure you guys have seen some of these harmful algal bloom pictures of Lake Erie. This is, these have been all over the news in the last few years. This is the Western Basin here. And here you can see where the Maumee River is coming into that. As I said, the Maumee watershed is primarily agricultural. And so hence therein lies the problem. So in our work, what we've mostly been trying to do is look at what the cost effectiveness is of various nutrient management policies. So best management practices, including cover crops, filter strips, the so-called 4 Rs, right source, right rate, right time, right place, as well as things like a fertilizer tax. Now, a fertilizer tax is not something that people like to politically talk about, but yet, it provides a good baseline because we know that's the right thing to do in terms of internalizing the externalities. And so in comparison, we can look at the cost effectiveness of these various cost share programs for best management practices. And so that's some of the work that we've been doing and that Hung Zing shared with you earlier. But the basic approach here is 3 things. It's a farmer decision-making model. Typically, we're doing collecting survey data to estimate the parameters of that decision-making model because we're interested not just in the economic effects. So for example, a subsidy or a cost share program and how much that's increasing adoption rates. But what we're also interested in is the heterogeneity of the behavior. Farmers, some see themselves as being very strong in terms of an environmental ethic or conservationalist. Others might just be simple profit maximizers. And some of this work reflects some of the collaborations that I've had with behavioral scientists who started the project by saying farmers aren't profit maximizers. And then we had long discussions about that. And we finally got to the point where we're like, no, farmers are profit maximizers. There's some that also care about the environment. And so and the data has borne us out on that. So that's the farmer decision-making modeling part of it. That then gets integrated with, the results of that model are used to predict land management and land use outcomes across an entire region. So in this case, across the Maumee watershed. And so we're basically using the empirical parameters to then generate a spatial prediction, a map, as my ecological collaborator likes to say. And that then is an input into the hydrological model. And for those that know anything about this area of work, the hydrological model that we're using is something called SWOT, which is a very common model that will model the flow of water and the nutrients, of course, along with that. And so the outcome of this is SWOT then generates predictions about what the dissolved reactive phosphorus and total phosphorus loadings are that are loading into the lake from the Maumee River. And so what we're doing is tracing through policy incentives, payments to farmers, through decision making, through land management and land use outcomes across the watershed, through nutrient loadings into the lake. So some of our findings. To date, heterogeneity matters. There are significant differences in behavior, and we see that those matter in terms of the decision making. Cost share payments are effective. Farmers respond to economic incentives. But here's the interesting thing that we find through the integration of these models is that while cost share might be effective in terms of incentivizing farmers to adopt, even though farmers are adopting, the impacts on water quality outcomes are far less. And so this is evidence that there are things like legacy effects. It takes time for the phosphorus to just because we're not putting quite as much on this year, doesn't mean necessarily that we're going to have a better outcome this year, right? It's going to take time for that to filter through the system. And so it might be 5 years down the road that the lack of application of phosphorus is actually showing up in terms of water quality outcomes. And so that's one of the political economy implications of this, is that it takes time, and we're not going to see immediate return to any policy. And so that's an important aspect to message when it comes to interactions of policymakers with the public. The other thing we've done is a little bit of work on public preferences in terms of policies, and found that residents actually have a preference for reducing nutrient pollution through either regulations or payments for ecosystem services, but not a tax. All right, so political economy matters. One of the benefits of doing this kind of really detailed work is that we've actually been able to pass a lot of this information on to the policymakers. And so we are in conversation with the governor's policy team as they are looking at options. It's not going to be a tax, unfortunately, but they are looking at other options for what they might be able to do. There are some nagging challenges to this work, the integration of the spatial mismatch. So you've got a very highly detailed model of farmer behavior at a field level. How do you integrate that across the whole region? You're really relying on matching up data that is at different spatial scales, and so that's just inherently a problem for us. Another issue is in terms of, once we do that, we then have to integrate with the SWAT model. So again, there's some mismatch there in terms of both spatial and temporal resolution. But those are issues that we're working through and dealing with to the extent that we can. And I think that we've kind of pushed these models as far as we can go in terms of the analysis part, the policy analysis. The bigger challenges are, if we now think about this from a sustainability perspective, is that these models just they don't really get us to where we need to go fully, right? So for one, they're not, and the biggest part about this is that they're not dynamic, right? They are a static snapshot based on observed data and whether that's survey data or GIS data, but they're not, there's no endogenous price feedbacks here, or market or non-market feedbacks. There's no dynamics. There's, farmers, when we're modeling that decision, it's static. We're not modeling them with expectations over time. So we're not able to account for uncertainty, which is certainly a big issue in terms of decision making. And so ultimately, you can't use these models for assessing sustainability in the way that we would like to, as I talked about before, in terms of finding this middle ground approach to looking at weak sustainability, but accounting for some of these more realistic dynamics. So we proposed a new project, which we're now in year 2 of. This is the Infuse project, which is the innovations at the nexus of food, energy, water systems. And anyone who's done an NSF proposal, and I don't know how many of you have, how many people have done that? So when you write an NSF proposal, you know that, you have to have the kind of cutting edge research has to be there, but you also have to have a hook, right? You have to have like a sexy question that you're asking. You can't just do you can't just justify the work because the research is good and it's cutting edge in some way. You also need kind of an interesting hook. And part of that, I think, is because of the interdisciplinarity of these things, right? You have to have something the people, regardless of their discipline, can wrap their heads around. And so we got lucky with this hook. So we were writing this proposal right as our president was coming into office. And we were wringing our hands about that, just to be honest. And thinking about, well, what might the implications of this be for food, energy, water systems? And of course, issues of trade and trade wars were swirling around in the air. Nothing had actually happened at that point. But we thought, well, what if you were in that world? What if you were in a world of trade restrictions, and ratcheting up of tit-for-tat retaliations? What would happen to the impacts on the land in a region. In this case, we were looking at the Great Lakes region. What would happen in terms of food production? What would happen in terms of how agricultural sectors are adjusting to being shut out of global markets? What would happen if, in addition to that, there might be changes in terms of labor and in immigration shortages? What would happen? And then on top of that, we added the question of local foods. Well, what if in a happy world, all of a sudden everyone was willing to pay for local foods? But regardless of the source, the point is we were asking these questions about what we called deglobalization. So what happens if we enter into a world in which things become more and more deglobalized? So NSF liked that, and they funded us. We're in our second year of that. This is the project team, and it includes a couple of the people, in addition to myself, Robin Wilson, who is the behavioral person, and Jay Martin, who's our ecological modeler, the watershed modeler. So they are from the previous work, and now also on this team. And importantly, it includes this guy, Young-Yang Kai, who is a dynamic economic modeler. And so because of his abilities, we are able to think about how we might introduce dynamics into what we're doing. And then I'll also point out, just for those of you who might be familiar with Alan Randall, brilliant man, love working with him. Ian Sheldon, who is our resident trade expert. So, it's interesting putting these kinds of teams together. Ian has, been an agricultural economist for his whole entire 30-plus years of career, has never done any interdisciplinary work. So this is his first experience with that, and that's been fun. It is actually a great team. So we are looking at the Great Lakes region. It's a 5-state region. It's kind of the intersection. Here you can kind of see it. These are the Great Lakes here. So we've got Michigan, Ohio, Indiana, Illinois, Wisconsin. And we basically were we've collected most of our data and doing most of our analysis based on state boundaries. And the argument here is that this is very much an agriculturally important area. And it's also an area in which there is the so-called Great Lakes mega region in terms of kind of a network of cities and economic activity. There's about almost 40% of the land in crop production. Great Lakes have 5% of the global fresh water. Agricultural accounts for about 10% of the exports. So I want to just share with you some highlights from this work. I won't have time to really dig into it too deeply. But one of the primary aspects of this work is to link the integrated modeling that I discussed earlier with a more dynamic framework. And so the dynamic framework that we're developing here is at the regional level. It's a dynamic regional economic model of the economy that is a general equilibrium model. And I mentioned Young-Yang as having some expertise in this. He joined OSU a few years ago. Before that, he was at Stanford, and he was working with some of the global models, including DICE and stochastic versions of DICE. And so he's brought that expertise, and he very foolishly agreed to actually develop a new model at this regional scale. And so it's been a lot of fun engaging in that work. So a big piece of this, in addition to developing the dynamic model, is of course you have to have conditions under which that model is running into the future, right? And so you need to develop scenarios. And so we've gotten into this whole scenario development world, which again, I don't know if any of you have had any of those kinds of experiences. So if you think about, for example, the IPCC scenarios, right, that they've done for those models, it's a lot of work developing those scenarios. I had no idea, but the idea is that you could do 10 bazillion different scenarios, but yet you only have time to do really a small handful. And so thinking about what are the relevant scenarios that you want to run. Of course, you want to make them relevant for stakeholders and for policy. And so it has required us to engage quite a bit with policy stakeholders and other stakeholders from the region. And so as a result of that, one of the persons on our team is a sociologist, and that is his expertise. He actually engages and does participatory modeling work. And so that has been another good experience, interesting experience for those of us who aren't quite engaged in that same way. I would say on the whole, it's been good. It's been interesting watching Alan Randall respond to that. All right, so let me talk a little bit more about these scenarios because they're very important. I mentioned we've engaged a lot of stakeholders. Essentially, where we ended up with this 2x2 idea of a matrix. Okay, and so think about this in terms of what are the dimensions along which we want to generate these scenarios. So clearly, we're interested in trade, and so low trade, high trade, and differences in scenarios across that continuum are of interest to us. The other continuum we decided would be something about the policy world in terms of the commitment of policies to environment and to sustainability. And so we have the other axis being stronger versus looser environmental protections. And so within that, what that naturally led to was 5 scenarios, right? So you've got the business as usual scenario, and then 4 alternatives, basically a high, a high, low, low, right? In terms of those 2x2s. And we spent a lot of time with stakeholders kind of talking through this and figuring out what the different examples might be. So just to give you an example, in terms of the high environmental protection, low trade openness quadrant, this is an interesting thing to think about, right? So that you have low trade, so a lot of protectionist kinds of policies, but yet also policies that are protecting the environment. Maybe not the most common combination of things, but plausibly an outcome that could happen. And so in this world, you have things like climate benign energy, land conservation, water quality, strong environmental protections, but you also have protectionism and nationalism in terms of trade and the environment, so more isolationist kinds of policies. All right, so that is the exercise that we've gone through on the scenario development side. The dynamic regional economy model is something that's still very much being developed, but it is a general equilibrium model, and so we've kind of given preference to some sectors in terms of modeling those sectors. Not surprisingly, agriculture and energy are 2 of those sectors, given the questions that we're trying to ask here. And of course, ecosystem services are an important part of this. And so here you just see a schematic. This is representing the regional economy, and then of course we've got this interaction with the rest of the world too. In the current version of the model, this interaction is fairly small. It's just basically in terms of import and export prices that are exogenously set right now. But you'll see just simple examples of that in just a second. In terms of the guts of the model, it's really being developed as a social planner model in which we have multiple sectors in terms of the food sector, so corn, soy, wheat, livestock, and specialty crops. And then land and land allocation is an important piece of this, right? Because at the end of the day, what we're interested in is how is land and land use changing in response to all of these global conditions that are altering markets within the region. And then we're interested in the emerging energy markets for land-based production of energy. So things like wind, as well as biofuels. And so that is also in the model. And then in the dynamic general equilibrium version of this, we actually have firms who are profit maximizers. We assume households own the land and own the capital, and they get a share of all the profits in terms of the firms. All right, let me just show us some simple examples here in terms of baseline and alternative scenarios. So here we have a simple example of increasing so the scenario being an increase in export prices for soy and corn. And so here you can see the BAU is the dotted line for corn. So this is going from 2018 up to 2030. The solid line here is the BAU, or the business as usual case, for soy. So in each of these cases, increase in export price. In the alternative scenario case, we've got increasing crop exports, both for corn and soy. And then if we look at what the prices are doing, they're all going up. Why are they going up? Because there's surplus profits in these areas, and that all is getting capitalized into land values. And so as a result, commodity prices are going up. So the model is capturing some basic dynamics. Certainly we would want the model to capture these things such as land capitalization effects. And then we can look at how the model is capturing actual land reallocations. And so this is just, I'm showing you very baby steps. You know, it has taken a whole year just to parameterize the basic production functions that are in this model using historical data. And so we're finally getting up and running in terms of being able to run some of these scenarios. This one was looking at a reduction in oil imports into the region, and interestingly shows that in addition to increasing oil extraction, which you would expect, the actual investment in renewables goes down because it becomes more expensive to produce energy. And so there's less, households are the residual owners of capital, and so there's less capital in the future for them to invest in renewables. And so it raises at least some interesting questions and some interesting puzzles to think about. All right, I'm not going to spend really any time. Let me skip over the integrated land use watershed modeling piece of this, because that's pretty similar to what you've already seen and what Hongxing talked about this morning. And so just know that as we're doing this work for this project, we're actually in the field again doing another round of surveys. And so we've just gotten those data in, and we're estimating models that are farmer decision-making models. But rather than looking at land management, in this case, we're looking at land use. So the idea is that we're modeling the same land use decisions at this individual scale that the dynamic regional model is modeling at this aggregate scale. And so one of our big modeling challenges is going to be, how do we integrate those two things? Because we've got a lot of detail at this individual level and a lot of dynamics at the aggregate level. And you know, ideally, we want to have both, because both matter in terms of assessing impacts and doing the sustainability assessment. But that is really one of the biggest puzzles of this kind of work, is how do you integrate those two disparate scales? So let me skip, I'm just going to skip through the farmer data stuff and the field level stuff. Just make a note that we are still thinking about, as I said, this integration piece. Lots of whiteboarding sessions have been going on. The last piece in terms of this that I want to highlight for this model is exactly how are we thinking about doing the sustainability assessment piece. So this is how do we implement the kinds of weak sustainability plus approaches that I talked about. So we're working with an engineer, a process engineer who models in very specific ways production functions. Okay, he thinks about production in ways that are really different than we do. Right? In many of our meetings, you know, we're talking about modeling production, and we've talked about, well, should we use a Cobb-Douglas function? Should we use a CS function? And then his question is, well, what about the first law of thermodynamics? I don't know. What about the first law of thermodynamics? Well, I think your production function might violate that. Like, you know, this is not anything that as an economist I've ever thought about. We had a very interesting discussion about the first law of thermodynamics, which, as you may know, is about energy conservation. No energy can't be created or destroyed, which apparently then also translates into mass. Mass can't be created or destroyed. And he, as an engineer who's very interested in accounting for every, you know, unit of that, is very concerned that our production functions are not respecting the first law of thermodynamics. Is a very different perspective. And so, you know, while I certainly laughed and still chuckling, on the other hand, you know, I wonder, there's got to be an interesting research question in there someplace, and you know, if we can keep having that conversation, we'll get to it. So there are really interesting challenges here as we think about trying to combine some elements of the weak sustainability and strong sustainability approach. And as I said, again, I hinted at the beginning, we're really trying to think about how do we do this at a regional scale. Again, thinking about the openness of a region, how do you account for that as you think about assessing sustainability? And so we've done some pretty high-level conceptual thinking about that, and come to the conclusion that we think that, I don't know if this is a theorem or what this is, but we think that the role of trade is actually more important at a regional scale than it is at a national scale when you're thinking about sustainability. So it's actually the flip of what most people, maybe non-economists, would think about when you think about the role of trade and sustainability. But the idea is that because at a regional scale, most regions are going to have far fewer of the resources that you ultimately are going to need to sustain yourselves, trade is naturally going to be more important. And the smaller the region, the more important that's going to be. What are the implications of that? The implications are that, number one, trade is essential for sustainability. But the other implication is that as a small region, that region needs to make sure that it is retaining enough wealth so that it has the ability to trade. Right? And so there's some interesting implications there that we're thinking through about what does that mean in terms of a sustainability approach or policy and evaluation. And one thing that it means is certainly a small region would have to be able to pass a weak sustainability test, but maybe it also means that there would be a rationale for a strong sustainability set of kind of critical capital stocks, whether those are natural or human capital or health or something that that region needs to maintain so that it has the ability to generate the wealth that it needs in order to maintain that weak sustainability approach. All right, that was a rushed way of trying to explain some of our thinking there. All right, the last thing I talked about thermodynamics. The last thing I wanted to wrap up with, if I have a few more minutes, is the Finichel et al. Survey, and share just some initial results with you all from that. As you may know, we had an online survey that went out over the summer. We've gotten a pretty good response rate from it, about 9% so far. We sent out, now the sample was generated based on authors who'd published in environmental or resource economics or natural science journals over the last 5 years, and we had a subset of journals that we were gathering that information from. We ended up sending out emails to almost 20,000 people. Of those, about 17,000 were actually valid, so pretty good. And as of this week, we've gotten a little over 1,500 responses. All right, so this, unfortunately, is too small for you to read. I apologize, I didn't have time to make it more legible. But this is the distribution of responses by journal. So I don't know, can you guys read it? Kind of? All right, so here's AJE up top here. So here you can see these are the number of emails we sent. These were the number of emails that were good. Those are the finished responses. And so our response rate is about 33%, about a third of all authors who'd published in AJE in the last 5 years that we contacted actually responded. All right, so conservation, biology, ecological applications, you can see the list of journals here. Skipping down here to some others that you may know and love. For example, Journal of Environmental Economics and Management, JEEM, we've got a response rate of 27%. Jerry, response rate of 40%, which we were super thrilled about. Land Econ, response rate of 50%. So we've gotten, I think, a pretty good handle in terms of the pulse of what people are thinking of here. So one of the questions was, what motivates you to do research? And I thought this was interesting. So, by the way, it wasn't just economists responding to this. This was also natural resource and physical scientists as well. And so here you can see the field. So here we have ag and applied economists, and we broke out economics, kind of general econ from ag and applied. Humanities, we actually had a couple of people who were in the humanities who responded. Natural science and engineering, and then non-economics social science. So that might be people like, sociologists or psychologists or others. All right, so this is what motivates you. Do you care about the analytical framework? Do you care about career success? Do you care about detailed descriptions of data and of what you're observing? Do you care about extending theory, hypothesis testing, influencing policy, or developing a mechanistic understanding of the underlying processes that are at work? So ag and applied economists, 30% care about influencing policy. That was the number one response. And then the rest fairly evenly distributed, although lower on the theory part and a little bit lower on the career success part. In comparison, economists were also cared about influencing policy. So economists who are outside of ag and applied econ fields, in other fields, 21%, a little bit higher on the mechanistic structure and understanding and analytical frameworks. Skipping down to natural science and engineering, there was much more on the mechanistic understanding of structure and less on influencing policy. So just an interesting divide culturally in terms of what people are trying to do in terms of their research. We ask about how do you value multidisciplinary work, and interestingly, in terms and how do you evaluate the quality? So this is the multidisciplinary project would be much lower quality, all the way through the multidisciplinary project would be much higher quality. And this is both, it would be similar. So if you were to compare a multidisciplinary project with a disciplinary project, the outcome here is, if you focus on these two, so these are the ones that would say that the multidisciplinary project would be somewhat lower, either a lot lower or somewhat lower. Less than half of ag and applied economists responded that way, so that means that more than half thought it would be at least similar quality, if not greater. Economists, more than half responded it would be much lower or lower quality. And so, again, some interesting differences in terms of culture. The natural science or engineers, only 18% of them thought it would be much lower or lower quality. And so they're much more positive, it seems, in terms of the quality of the multidisciplinary work. The last thing I want to share is from the choice experiment we did. We said project A, project B. Project A gives you this number of journal publications distributed across different kinds of journals looking at general interest science, so things like PNAS and Science, Nature, top level field journals in economics, top level field journals in science, and then also general interest econ journals, so the top level econ journals. And so as a conjoint experiment, people chose project A, project B. Here are the trade-off ratios. These are super interesting. 1 minute, okay, this is my last slide. Here are the trade-off ratios. Okay, so this, this top table is looking at, in terms of all the other types of publications, and then general econ in terms of that, right? So you've got general econ on the top here. So for example, and then here you've got the different fields, people from different fields and then people from different departments, broken out both ways. So for example, all respondents rated a general econ publication relative to a general science publication as a 0.6. So, almost a 2-to-1 ratio. But of course, not surprisingly, the econ field would give it a greater than 1, right? So we would care more about having a general econ publication than a general science publication, and we would rate for every, for every one general science publication, the equivalent would, we would get a bigger bang for a buck from general econ. This one down here then rates it in terms of general science. Okay, so this one is also pretty interesting. You can see that in terms of, for example, looking over here, how many field econ journals are equivalent to a general science journal. For all respondents, they would give that a 4-to-1 ratio. And even within the field of economics, people on average gave that a 2.1 ratio. So meaning that for a general science publication is equivalent of 2.4 field level econ publications. I don't know what happened. It says no disk. Maybe that's, are you telling me that, Ben, that it's done? That we're over? I don't see that there's another button here. Okay, anyways, that was my last slide. Huh? Yeah, no, I mean, those trade-off ratios are interesting to look at. You guys might want to ponder them. The other thing that was interesting about the trade-off ratios is that even scientists, natural scientists, cared about publishing in econ journals, and vice versa, but that those ratios are actually different. It seemed like the natural scientists actually valued more a publication in an econ journal than vice versa. So it's, there's some interesting results there if you dig into it a little bit. Unfortunately, you can't look at it because it's not on the screen right now. It's a mystery. All right, why don't I wrap up and I will take some questions. And that was the end.
I have a question about the survey results. So I was curious to know, first of all, kind of what was your motivation or reasoning kind of behind embarking on this endeavor? And then second, kind of, what are the main takeaways you take from the survey? And then what are the main takeaways that you take away for young people in the profession from the survey?
Wow. Great questions. We have only just started looking at these results in the last week or two, so I don't have very refined kind of thinking for you on that. But in terms of, but let me just give you some quick responses. In terms of our motivation, we had so Eli, Bill, and I had done a session at the World Congress back a couple of years ago, and it was on basically this kind of integrated modeling stuff. And after that, we were kind of comparing notes about what our experiences had been, and we had some very similar experiences, but also different experiences. And so some of the similarities were, just things like different understandings of how to even think about a research question and how to think about a model. So for example, in some of my experience, I have worked with people from other fields who are completely dismissive of empirical models. And that was a real mystery to me to understand why that was. And it turned out that they had no understanding of how one could use data to identify a causal relationship and just assumed that any empirical model was just correlation. And so that was just once you kind of help them understand that there are actual methods to do this, right, you can make more progress. So we basically, the motivation was we've had some similar experience, some different experiences, but we all thought it was important. But important also to do work that was high quality, and not. And so we were curious what other people thought. Did other people think that you could do interdisciplinary work that was high quality, or by definition in people's minds, did interdisciplinary work always mean it was somehow lower quality? Were you making a fundamental trade-off there? And I would say that just based on that quick table that I flashed up, I think both are true. I think people believe there, but I think all of us were a little bit heartened to see that for the applied areas. So this wasn't true of economists generally, but for applied economists, there was slightly over half who thought it was at least as good as, if not better. Of course, it all is contextual and depends on the question you're asking. In terms of the takeaways particularly for younger professionals and people who are maybe more junior, there's a lot of questions that we ask that are going to help us get to that we actually haven't looked at yet. But definitely the feedback has been generally it does take a lot longer to do interdisciplinary work. So just the lag in terms of returns is much greater, and that my other colleagues don't necessarily understand what I'm doing. So there's that perception issue, and so there's still, I think, a cautionary tale in terms of people who are at a more junior level doing that kind of work. But again, it is also very contextual. So for example, we had some applied economists and general economists who are actually in multidisciplinary units. And so for them, that's a very different experience.
And just a quick question. I was wondering how you were defining someone as being an agricultural or applied economist versus an economist. Was it from their training or from where their current department is, or because that seems like a fuzzy, I don't know how I would fit in that, for example.
It is fuzzy. We looked at the PhD, and so where people got their PhD, which they told us, right. That was on the survey. And then, so that was in terms of training. And then in terms of department, we looked at department. So, and we actually broke that out as two separate things.
Cool.
Yeah.
And the other thing so I guess, when I feel like there's so many different levels of what could be interdisciplinary collaborations,
Yeah.
right? And it strikes me that, kind of what you're describing of your work is sort of like a very complex level of interactions.
Right.
the kind of thing that I've experienced of being asked to do and maybe declining to do was kind of like, would you help us do a cost-benefit analysis of, this bat thing, whatever, we need an economist. And while I feel like and I was glad one of my colleagues was willing to do it. So I didn't feel guilty about saying no, but I felt like it was, so when you're being asked if something is important or high quality, we have this idea, I think, within our field of we're kind of defining if what we're doing is important based on how new it is, right? On how groundbreaking it is, as opposed to giving value. And I actually now feel like we need to rebalance that more, because I feel like there's such value in us being able to do some bread and butter things for people understanding a little bit kind of the economic reasoning in what they're doing. So I think there's quite a high value to kind of humanity for that, probably, and us understanding what they're doing too, right? Not to be completely economic centered, but
Right.
but it's certainly not new and different and groundbreaking.
Right.
Right.
Yeah. No, and I think that is a constant struggle. And I think that's interesting to look at what people's motivations are for doing the work that they do, right? And even, people, 30% of applied economists said policy, but even within policy, that is a broad, right? You could be doing many different kinds of work to inform policy. But I do think, I appreciate your point about usefulness of the work versus groundbreaking and what's going to get published. And that is a constant trade-off. I think that, for people who want their work to be relevant, but we also want it to be impactful in a scholarly way as well. And sometimes, if you're lucky, it can be both, but sometimes there's, a trade-off there.
Elena, I was interested in your point about the first law of thermodynamics.
Have you had that conversation too?
Well, in an indirect way, and this is what I want to ask you. So, a number of people, eminent among them is Madhu Khanna, has done work on pollution as a residual, particularly in agriculture. Things that end up where we didn't intend them to. So we apply nutrients, but they didn't all get into the plant. And when you think about common assumptions with production functions, which is that they're concave to the origin, and so they have diminishing marginal products, we are fundamentally, if we assume that, then and if the input is in physical units, then the part of it that's not adding to the product is going somewhere else. Should we be thinking about measuring residuals?
I think yes. My answer is yes, obviously. But I think my engineer colleague would be emphatic about that. I mean, when I started talking to him about unobservables and whether they're correlated or randomly distributed, he didn't get it at all. He was like, well, we have to be able to measure everything. And so it's just a different approach, right, and a different frame of mind. But I think the broader question there is, when does it matter that we measure everything versus, from our point of view, it matters because of the damages. It's a welfare-based argument, right? And so there's always going to be a fundamental disconnect there, depending on whether you care about the physical quantity of something and tracking that versus you care about the welfare implications of something. But I think in the example you gave, and many pollution examples, those things actually align.
Hey, Elena. Great talk, as usual. So I guess my question is, what has been, this was from the perspective of authors, which journal they'd like to choose, but from your experience in trying to publish interdisciplinary research in disciplinary journals, what has been your experience of that? And in particular, so disciplinary journals are often looking for something that is groundbreaking, and and often, when you're doing interdisciplinary research, the groundbreaking thing is really the fact that you were able to combine all this complicated models, you were able to deal through these issues, which are sometimes difficult to communicate. But so that's sort of.
Yeah, no, great question. I mean, I think the ideal project that would be this, highly complex kind of, large interdisciplinary project is it has to have multiple outputs. And so, and particularly anytime you would have a graduate student or a junior person on a project like this, you absolutely have to make sure that they're going to get what they need out of the project, which, in our profession, it's going to be they need econ publications. And so you have to be absolutely sure that they can, or do your best to help ensure that they're going to be able to get those kinds of publications out. And, I think luckily we're in a profession where, we highly value work that is applied and asking critical questions about impacts of environmental pollution or whatever it is. So I think sometimes we talk about doing work that is quote unquote in service to the project versus doing work that is publishable in our discipline. And I think that that's a good, honest conversation to have. Because sometimes the work that is quote unquote in service to the project, particularly in a project like this, it's not going to be the groundbreaking stuff, but it is the stuff that could get you in PNAS or Nature or some of those journals. And those, I think increasingly quote unquote count in more and more of our academic units. And I would look to you guys too. You guys have published in those places, and many of you have, and just be curious to know what your experience has been in terms of that. But I know, at least in our department, we do highly value a publication that would be in a general science journal like that. And so I think that is, without that, I think getting economists involved in this kind of work, so going back to, kind of the beginning opening statement, this is at the heart of economics, and I truly believe that it is. But, we have to make sure that we're incentivized and rewarded for doing this work. And I think that increasingly we are in departments that are recognizing that. Although I do think seems to be a cultural distinction between a straight econ department and an agricultural and applied econ department. And that still is, in my mind, concerning, that there would be as much of a distinction as we saw in the data there.
Thank you very much.
Thank you.
Small token.
Thank you.